So now that we've looked at how an airplane works, how wings work, we talked about stability, we've even designed gliders. How do they get around? How did early pilots know where to go and how to get there? So one of the ways they used was just flat out observation. They looked at objects that were around them. And you think about this, we kind of do this today. An example, let's say you have a friend that lives in the neighborhood and you want to tell that friend how to get to your house. Well, you go off of Easy Street, take a left, and go towards the sunset. If it's after afternoon, the sun sets in the west, so we know that. So go towards the sunset, 3 blocks, take a left turn, go south until you see the big red house, and then we're across the street from the big red house. Just simple observation. They've also used maps. Today we use something GPS, which is probably what your generation is more familiar with. But when I was growing up, we used maps. It was not uncommon to, when you were driving in the family vehicle across the country, to stop at a rest stop when you got to a new state and get a map and figure out how long it was going to take you to get from where you were to where you were going. And you would look at all the different roads. If you look at a globe, you're going to see longitude and latitude lines. So latitude, and this is important to understand, the difference between latitude and longitude. So they're just imaginary lines. So latitude runs east and west, which is down here at the bottom, but it really measures north and south. So how far are you from the equator? So the equator is 0, north and south poles are at 90 degrees. And then lines of longitude, they run from the North Pole to the South Pole and continue around. So those are called lines of meridian. And 0 degrees goes through Greenwich, England, which is basically London. There's a Royal Observatory there that is the standard of time. That is like the 0 time. That's where it's set. So we use those. We don't use those as much anymore, but we will in this class. And aircraft still use them. We don't think a lot about them today when we're driving to school or the store. Finally, a compass. A compass you're probably familiar with. You actually have one on your phone, and the way a compass works is it uses the Earth's magnetic field. So we know that you've played with compasses or magnets rather in science, and you know that they have a north and south pole. So does the Earth's magnetic field. So if you have a compass, whether it's a toy compass or your phone, they act the same. So they point towards the Earth's North Pole. One thing that's really important, though, is that the Earth's North Pole, magnetic pole, is not the same as the geodetic North Pole, or geometric North Pole, if you will. They are different, and pilots have to make accommodations, especially when they're flying over the North Pole. When sailors and seamen were going across the oceans, they had to find out where they were, and they used a couple of different methods. So in the lower right, you see something called a sextant. So a sextant measured the angle between you and a given star. What's also missing from this slide are clocks. Having an accurate clock was super duper important. So if you knew the time and you measured the angle with your sextant, you could get longitude and latitude. So a sextant measures your angle from a given star. For example, Polaris, which is a North Star, which doesn't change in the sky. Its position does not change. So you can get your latitude, and then you can get your longitude by measuring time and where you're positioned from another known star. A Walker log is the device that's on the lower left there, and that was used to measure speed. So you can kind of think of it as like an early speedometer. So they would put the little spinner-looking thing there in the water and attach the dial to the boat, and the rate at which and I forget what it's called, the rate at which that spun would spin the dial, and that would tell you how fast you're going. So it's kind of like putting a simple speedometer on your bicycle. Early pilots, early airline pilots, in the early 1900s, they navigated by sight. So eventually there were some towers that were set up, and the line of sight had to be used. If you were flying in foggy weather or rainy weather, or if you were too high, or if it was cloudy, that could cause a lot of problems. They didn't use radio at that time, so you had to see basically a beacon. Today we use a lot of different radio navigation. So that can cut through, depending on the radio frequency, it can cut through clouds and rain and so on. So we're going to take a real quick look at all of these. There's LORAN, there's non-directional beacon, ILS, VOR, and GPS. So we're going to take a look at some of those real quick. So LORAN stands for Long Range Navigation. And there's different versions of it. There's A, B, C, and some others. And C is no longer used. It was originally developed during World War II and was used for ships. So they would have bases posted at different locations in the ocean, and it was used for nautical navigation. But now it's used, not used as much, but it is used in aviation as well. So you could, as an airplane, look at a beacon and look at other beacons, compare how long it took you, where those positions are compared to their known positions, and do sort of a triangulation. A lot like what cell towers use today to find your position. So it's basically geometry. Non-directional beacon, I kind of think of this as if you walk into a room and there's a little light bulb, not like a big bright light, but maybe like a little light bulb, and you want to find that light bulb is a waypoint or an important point in the room. So obviously, if you can see the light bulb, you're going to walk towards it, or maybe you have a direction that you want to walk away from it. But that light bulb basically serves as a beacon or a point of reference. So that's really kind of how NDB works. VOR, which stands for very high frequency omnidirectional range. So it's something that's sent out in 360 degrees, just like a light. So it's like NDB. And it's commonly used in aircraft. Aircraft have a VOR indicator, and it basically acts just like it. It's just at a different frequency. So you set your instrument to fly towards a VOR, and you use that as a waypoint or a reference point. ILS stands for Instrument Landing System. And these are used typically on the ends of runways, just as you would imagine by the name. And it tells you if you are too far left or too far right, or if you're too high or too low. So it helps you adjust your glide slope. So that obviously you're not going to use that until you're fairly close to an airport. And then finally, something that you all probably know, GPS. We have these on our phones these days. Something 10 years ago that really didn't exist. You had to buy a separate unit, and you can still buy separate units. But GPS, Global Positioning System, it is U.S. based system. It used to be used only by the military. It became operational in 1995. At any given point, you should be able to not visibly see, but you should be able to detect with your phone or your receiver 8 satellites at any given time. You actually only need 4 satellites to get a good fix on your position. And it basically uses geometry and time as well. Something that a lot of people don't know is that because of the effects of relativity, that GPS clocks have to be reset every day. They are off by just a few billionths of a second. But if that isn't reset, your error could be your route could be off by 6 miles. And it would be off by 6 miles every single day. So that's it. Here's a few references, and we'll get started with some other topics in navigation.